Robin
So,
from South Africa.
Yeah, apologies for that. I'm presenting on behalf of Alistair and Hanlene today. As mentioned, I'm going to be sharing just a short note, a study that forms part of a larger study, and essentially is a pilot that looks at the applicability of camera traps for surveying Rallidae species within wetland habitat. So this is a small study that we conducted last year and published early this year, and from then have built on following that. So I thought, just for context, in terms of looking at camera trapping and using it in a more kind of, well, first of all, a newer habitat type, at least in the context of South Africa, I'll provide some history and background to camera trapping. Starting from the present, going backwards, just for context, we use camera traps a lot. We throw it out there, but we often don't consider where it's come from. The first digital, fully automated camera trap was only really available on the open market by 2006. Prior to that, it was rather robust, heavy units that you had to preset in terms of exposure, often your focal distance and all the rest, where you presume the animal is going to be walking past. So the major surge was experienced in the early 90s, largely fueled by the hunting fraternity. The first digital camera kind of originated in 1975, and just to show kind of, I guess, allow us to really not take it for granted, it weighed a hefty 3.5 kilos, had a whopping resolution of 0.01 megapixels, and you really need to have a steady hand because it took 25 seconds to capture an image. And then, of course, the pioneer, what's also defined as the godfather of remote photography, is George Shiraz, who really pioneered this work between 1890 and 1905, and won, I think, in excess of 3 National Geographic Awards for his photographs. These are essentially the first photographs of wildlife taken remotely in the history of photography. So this was George Shiraz with his assistant, his camera trap, his remote photography setup, a magnesium flash gun, and this was his tripwire. He started it in the UK and then followed on to North America, and from there did some ad hoc work all around the world. National Geographic defined his wildlife photos as Shiraz's signatures because due to the magnesium flash, animals generally thought they were going to die and ended up getting these kind of shots of animals fleeing for their lives. He later on refined it quite a bit from these poor fallow deer that probably died from cardiac arrest to these much more applicable photos in North America. This is about 1903. This is the late 1890s. From then, this is what I was mentioned, the heavy, robust units, black and white images often have to preset where you expect the animal to be in terms of exposure, etc. Through to 2006, fully automated camera trap units that you can literally just load up, put out, and that does the job for you. In terms of camera trapping history, where we used it, the initial surge, 1990 through to early 2000s, was primarily in dense forested habitats internationally and focused largely on large felids, medium to large felids, tiger, jaguar, ocelot, really forming the bulk of the initial publications. But since then, it's really broadened out to so many different habitats and the plethora of species. In the South African context, the initial work was also done around forest animals, but since then also into grasslands and etc., etc. And important to note, still a massive focus on medium to large mammal species. So wetlands and birds, not to harp on it, but wetlands, particularly high altitude palustrine wetlands within South Africa, is our most threatened habitat type. It hosts a significantly large proportion of avian species, and no surprise, a number of these avian species carry fairly high threatened status. One particular group of avian species that, at least from BirdLife South Africa side, has really been notoriously difficult to survey, that is the crake, flufftail, and Rallidae genera within the family Rallidae. Why is that? They are largely elusive, cryptically coloured. They have a niche preference for dense aquatic marsh-like habitats, and they are ground foragers. So they're running around the ground in these dense habitats, which makes it immensely difficult when you want to study these species on a landscape level and try and determine population trends and their current status. The two primary survey techniques for these species are auditory cues, so sitting next to a wetland and listening for the call to get a presence point, or rope dragging, which involves the transect of observers walking through the wetland, dragging a rope and trying to incite a flush. So forcing the species to fly out, and then you get your record, your presence record. On the latter, there is, however, quite a bit of concern on the impact of consistent road dragging, with observers walking through often sensitive vegetation, as well as the invasive impact on the species, particularly when you're talking about threatened species. You're inciting a flush and you're possibly moving it from suitable habitats to less suitable habitats. And what does that do in terms of stress, increased predation risk, etc., etc.? On the former, auditory surveys, although effective, they're only effective on that species calling. So it needs to be primarily a breeding and territorial species within our range. Secondly, it's generally males advertising presence. And thirdly, if they don't call, you're not going to know they're there. And that's a big issue for a number of our crake species, which are Palearctic migrants or inter-African migrants. So this is the non-breeding range in the austral summer and Southern Africa. So they often don't call. Secondly, and the focal species of our work has been around this species. This is a flufftail species, Saurothera oresii, the critically endangered white-winged flufftail. We know very little about it, even though we've invested probably, at least from an ornithological fraternity, intensive work over the past 20 years. There are still big research gaps around its facets of its ecology and biology, and its population status and trend is largely data deficient. So we have low confidence in how the species is doing. What we do know is it's in significant trouble, and because quite uncommon to the Rallidae species, we have no vocalization recorded for the species in the breeding range and non-breeding range, which is bizarre for a Rallidae species. We've had extensive studies, published studies done in the breeding range, no calls, non-breeding range, the same thing. Low density, localized, and only known from, I think, probably 24 published records in South Africa, historical records. So very difficult to conserve a species when you don't know how to count it, what trouble it's in, what are the major threats. So the pilot study that we chose to test whether or not camera trapping could be applicable was Ingula Nature Reserve. The reason for that is it hosts a significant amount of continuous high-altitude palustrine wetland, namely about 1,200 hectares. It has 10 Rallidae species on the pooled nature reserve list. So important to note, a pooled species list is not a measure of current species richness, because some of those species were only recorded once and 8 years ago, but it gives us a measure of potential Rallidae species richness. And most importantly, it has hosted, it's yielded 2 sightings of white-winged flufftail over the past 8 years, which means that there is habitat on site that can be utilized for the species and does represent that which is applicable to white-winged flufftails. The survey design, we followed the recommendations by Bibi et al. And Royal et al. 2005, which was for low-density species and or species with very small home ranges, using an intensive survey grid randomly placed across the area that represents all the dominant habitat types. In terms of wetland, a high-altitude palustrine wetland, there are varied vegetation communities ranging from Typha capensis or Phragmites, which can be taller than 1.8 meters, through to sedge meadows, which can be about 30 centimeters in height. So you place cameras representatively across these, and we collected covariate data at each interval, which was ranged from water depth and cover through to vegetation characteristics. And important to note, we also, prior to the study, mapped out the dominant vegetation communities, following Davies et al.'s recommendation, but we built on it, incorporating drone footage, which made classification really a lot faster and a lot less labor intensive. Okay. In addition to that, we tested varied camera trap heights, as well as angles for varied focal distances. Unlike forests and scrublands, which I have most of my experience in, wetlands was a whole other ballgame. As you walk into a wetland, it is dense, and you now need to find a spot where you can put a camera up and not end up with pure false triggers of vegetation moving in front of the camera. You also need to anticipate where the species moves, and you don't often have defined game trails as often used in forest ecosystems. So it was quite challenging from that stage, and therefore we used a variety of placement techniques to see, trying to assess what was the ideal placement technique for Rallidae species. As a primary, because this was a pilot study, we purely looked at assessing species richness estimation across the site and accumulation over time. So we, as a primary measure, we defined concurrent sightings of the same species as being independent when separated by more than 60 minutes. And secondly, we collated our data to exclude any very small passerine species, this being less than 20 grams. These were particularly species that were not of interest anyway. These are warblers and waxbills. So number one, they're highly small, which is a detection bias issue. Secondly, they also have an alternate foraging strategy. So unlike ground foraging Rallidae species, they are forage gleaners, often sitting in the canopy. So we automatically just removed those and ended up with an expected list of about 15 target species. The results were really encouraging. Over the 566 camera days we accumulated, we recorded 90% of our expected species list within the one survey. Important to note that the expected list is derived over 10 years of counts on site. By 300 camera days, we hit asymptote and recorded 88% of the total species. Only included one species of the 300 camera days, and this included 4 out of our 5 expected Rallidae species, which was really significant, ranging from African crake to the most common African rail through to spotted crake, never before recorded at Ingula. Closest sighting to Ingula is 200 kilometers east at Sapi, and red-chested flufftail. So as mentioned, across the 566 days, also important to mention, 445 independent sightings of our target species. So you get a robust data set, unlike rope dragging where you get one presence point. You spend all that time going through the vegetation and we have red-chested flufftail. Where here, naturally, as a camera trap data, you get a timestamp, you get repeated data over time, presence, absence, and you get detection history, which you can work with later on the line. Of that 4 Rallidae species, most important here, red-chested flufftail. It's the most sympatric species within the southern Africa to white-winged flufftail. And then 4 non-Rallidae species, which are also of particular interest because all of them carry regional threatened statuses. So, for instance, wattle crane, critically endangered, grey-crowned crane, endangered, African marsh harrier, endangered, and African grass owl, vulnerable. Important to note, currently African grass owl, along many sites in South Africa, are surveyed through rope dragging. And here we present another non-invasive technique that probably could be more applicable to the species. The biggest take-home kind of result here is that 3 out of our 4 Rallidae species were in the top 5 most recorded species out of the 15 species, which is significant for us. So this means it's not only effectively recording them, but it's recording extensive data sets of our target species. Secondly, we confirmed that these species are highly localized. Even though our study site was small, following Royal et al.'s recommendations, surveying intensively in a small grid, many of these species were only captured at 2 or less cameras, but incorporated 60 to 70 independent sightings across the entire survey duration, which confirms some other studies that the territories of particularly red-chested flufftail, spotted crake, and species like that could be as small as 0.2 hectares, which is 20 by 30 meters. And from this, we started deriving what potential independence measures would be that we need to put between cameras if we want to design a robust survey grid to estimate site occupancy for species such as these. And then thirdly, tying the covariate data into our presence records, we could look at what was driving presence on site, and all of these corroborated what we know about these species. Red-chested being driven by vegetation height and cover, preferring taller, thicker veg, African rail wanting the presence of a trail and wider trails, wanting those flat, open pieces of water to forage with, etc., etc. So in conclusion, what I'd really like to just highlight is that our study effectively proved that camera traps are an effective measure of determining species richness of Rallidae, particularly the Rallidae genera. The ability to produce reliable, rapid species inventories was proven by 300 camera days. We had essentially maxed out the number of species recorded. And most importantly, when taking these recommendations of placement heights, placement angle, placement properties, and putting it into a more robust survey design, one can start estimating the site occupancy, population dynamics, and fine-scale activity patterns of these species. And as a little end-off good news story, the survey following this, one season on, we managed to record the first documented site occupancy activity patterns, arrival date and departure date of white-winged flufftails in wetland in Mpumalanga. So really exciting to see us slowly making progress after essentially was a 12-year stalemate in trying to conserve the species. So thank you very much.